Hi everyone, welcome back to our channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Ruben Vidal, who's done some projects for us. Today he's going to show us what he did for his final project, his course project of the course that we offer, which is ROS Basics in 5 days for a C++. Hello Ruben, how are you?
Hi. Oh, well, thanks.
Well, glad to hear from you again. And yes, you know the drill. So whenever you want, you can start sharing your screen and tell us what you've done with your project.
Okay.
Okay, we can see your screen now.
Okay.
Let me
Now
resize it.
I'll launch the main. Mm, let's see. The basic real robot project has three parts. Uh,
Mm-hmm.
First part is when we create a service server for Wildfinder that I divide in three sections. Uh, in the first section, go we go turn the robot to left or right, depending of the laser scan,
Mm-hmm.
which is update, and depends that we can move to the left or right in order to put in front of the wall.
Right. So the first part then is a service that uh, goes towards the wall.
Yeah, that's one part of the service server. The second part is getting close to the wall. So
Mm.
uh, I the robot move forward uh, to keep close to the wall,
Mm-hmm.
and then we can turn to the left in order to put
To be parallel.
in parallel.
Right,
Yeah,
right. And then the main
and then
program, which is following the wall, that's what's going on right now, correct?
yeah, yeah, yeah. When the service wall sends through, the robot end the task and
Right.
go to the other task, that is the
This
alarm
one.
record
Okay.
odometry.
All right.
So
So while it's moving, it is recording the odometry. And that's the
yeah,
feedback that we see, correct?
yeah, we see the feedback to the action client and the server's client and the server action.
Oh, so it
So
looks like we have a
yeah,
success.
finally, after doing one uh, lab, the the action server sends goal is succeed and the roll stopped.
Okay, okay.
So
Well,
so
that was pretty good. Um,
that's the code.
yeah, show us
I
a
want
little bit of the code, please, and
yep,
just
I want to explain the server wall CPP. That is a service server
mm-hmm.
with service quiz node. And here we can create a callback group in order to have two parallel functions, which are uh, the sub laser
Mm-hmm.
or the laser scan and the service server.
Well, technically, it's one part of those
Yeah,
to which are the callbacks, right? So each one of those has a callback, and that's why you do the callback group.
yeah. So laser server has a scan callback
Uh
in
huh.
order to update the laser scan. Second, service server firewall
Mm-hmm.
has a service callback in order to make the task, all the tasks that I explained before.
Right. And what do you have in the scan callback? Uh,
Oh, okay.
do you have a
Uh,
lot or a little?
no, a little bit.
That's great.
I just save the message ranges.
Yeah, perfect.
in a variable, which is a laser range. It's a vector of floats.
Mm-hmm.
So I save that, and inside of the service callback, I need to update. So I put the filter scan in.
What is that filter scan?
Oh, filter scan. It's I I uh it looks the paint or not? No, no, right?
I'm sorry?
All right. Now,
Oh, yeah, I can see it now. The
okay,
paint program. Yes, yes, yes.
yeah, okay. Uh, that's filter scan do. I need to update and select the minimum laser of the robot in front, right, and left.
Right.
So I create three vectors of float, which save this range of lasers.
So it's instead of just one point, you take like a certain amount of them.
Yeah.
And why is
So
that?
uh, uh, to in order to select a better laser
Mm-hmm.
and and keep uh, and keep a low error of the laser,
Right.
and, and that's it. So
Another reason maybe I don't know if it happened to you, but a lot of the times if you're just doing everything based on one scan value, sometimes that number, especially in sorry, in the real world, sometimes that number is an infinite or not a number, and then when you try and do operations with it, well then things weird things happen. Did that happen to you at all?
yeah, yeah, happened
Okay.
to me. So
Yeah, yeah.
that's
So
the reason actually.
yeah,
Sorry.
yeah. So you can take like a
So
mean or something, an average, and then you
mm,
can take care of that like
yeah.
that. Okay.
So for example, in front laser, I choose the lasers of 315
So
to 371.
you take like 20 of them. Yeah, yeah.
So I back in the front laser, and then I okay. Uh, uh, to this vector front laser, I choose the minimum element.
Oh, I see. Nice, nice.
So that's my variable min front laser, which is a float of the class.
Oh,
So
okay.
uh, with this, I can select a better laser
Right.
of the range of lasers that I choose.
Mm-hmm. And then that's the beginning of your server callback, and then you do other things, right?
Yeah, and that's all the server wall CPP. Oh, actually, I create the the object and run with executor with
Right. For the
multi-thread
multi-threaded. Yes.
and just spin. So that's the server wall.
Okay.
And on the Atom record, uh, first of all, on the constructor class, we create the action server, which takes the name of the server, that it's record Atom,
Of the
three
action, you
functions.
mean?
Yeah, server action, and takes three functions to this class,
Uh huh.
which is handle goal, handle cancel, handle set,
Okay.
the pointer, and the placeholders. The placeholders help us to uh, work with the property variable
Mm.
for for the function. For example, in handle goal, we have two variables to this function. There is UID and goal. So that's why
Oh, that's why you need
we
two
have
placeholders.
two placeholders. For the handle cancel and handle accept, just have one,
You have
because
one.
which is
Oh, okay.
goal handle, and on the left set, which is goal handle two. So that's why I use
Uh-huh.
these placeholders and create the publisher to geometry message, Twitch, and publish into the topic symmetry bell.
Do you have a multi-threaded executor here? What are you
Um,
subscribing? What are you because the server has a callback, correct?
yeah, but I don't need a I don't use a multi-thread here.
So
Uh,
you're subscribed to the odometry
oh,
somewhere, right?
the subscriber my odometry is inside of the execute
So you only
action.
subscribe to the odometry once you call the server.
Yeah.
Oh,
Uh,
that's a great way to
yeah.
doing it because you don't need it until then. Yeah, that's true.
Actually, it's because when I put the odometry subscription inside of the constructor class
Mm-hmm.
uh and start when the robot do the first task uh it takes the odometry,
Yes.
so I don't need that. I
Right.
need that when I start with the action server, the
Then
action
you
server,
take the
the
odometry. Yeah,
odometry
yeah.
it start with odometry, so
Makes
that's why I
sense.
put uh inside of the execute.
Makes sense.
um so well in talking about the execute, I clear the x vec and u vec, which is my vector floats, in order to calculate the Euclidean distance,
Right.
and uh, set the variables in zero. I send the goal, create a feedback and result variable, and the move variable in
And
case.
what's that
Uh,
sleep for? I see that sleep too. Line 101.
here, I use that just in order to prove that all works well.
Okay, to
But
like make stops in your code to make sure okay this is done, then it's gonna wait for 2 seconds. Kind of for you, right?
yeah,
Okay. Okay.
uh, and then I start with the feedback current total and update this. Uh, and for example, when the action server starts and the action client sends a goal, uh, I push this atom x and y, which is inside of the atom callback, which update these
Mm-hmm.
variables in order to obtain the position x and y of the robot.
Right.
So I push this vector, these float
You keep
variables
adding it.
inside the x and y vectors.
Uh-huh.
So now I can calculate the feedback with the Euclidean distance. And so if the feedback current total variable it's more than 5 toxic, I'd stop the robot.
Right. And then you break
Uh,
and then you return a
I
result somehow? Oh,
Yeah,
I see.
I return the result and say matches of goal succeed, and that's all the add-on record
Mm-hmm.
server. The most important part is the main, which has three classes. The first class is a service client, which uh, mm, uh, send
Like the
or
call to the
calling
server.
the server wall server.
Mm-hmm.
So in order to, I wait 4 seconds, and then I send a request, put my variable global of the class in false, service down, and send the result filter with the response callback. Inside the response callback, I wait for the status of the response for 60 seconds
Mm-hmm.
uh, in order to give time to the service server to
To
do the
complete.
task, to complete all the tasks. So uh, then we see what happens with the status. So it is ready as a result, or is if not, service is still in progress, or maybe
And what would
it's
happen
fine.
if you set that 60 seconds to say 5 seconds? So like less time for the robot to find the wall.
Oh well, if I do less time,
Mm-hmm.
maybe while the robot is still keep keep has the task,
Right?
uh the status and his time,
So
and
it won't return like a success, right?
no, he doesn't return to text. He doesn't return
Right. Okay.
services in progress,
Mm-hmm.
or maybe anything uh, that it could be
Right.
happen to me. So inside the constructor, I create the client, a timer. I use the timer callback to send all the requests
Uh-huh.
uh, just one time,
Yeah,
and
timer callbacks are
I can
pretty helpful. So does that
yeah.
mean you have a mutual again for the mutually exclude like the callback groups, do you have one here or no?
Inside of the service client, no,
Right.
I just the here. Oh, wait. In tutor class, tutor class is the most important because he takes the client tutor class and service
In this
tutor
class,
class,
yes.
service client class in order. So inside of the constructor, we create the object of service client class, and uh, we spinning inside this. So in ROS2, the service server are asynchronous.
Uh-huh.
So to convert a synchronous
Yeah, yeah.
a synchronous server, I do that. I put inside of the wall and spin.
Okay.
Meanwhile, service is done is false. So when the service server sends true, it means that the server wall ends with his task, and uh,
And we
I
can
s-
continue.
I wait 3 seconds and create a client turtle class, which is the action class, and
And
send
then
the
you
goal.
send the goal. And
Yep.
then you have to start the movement.
Yeah, of course. I will. Mm, yeah. The no client turtle class just send the goal,
Okay. Which is
and
the odometry recorder.
yeah, the geometry record.
Mm-hmm.
After this, I create a subscriber for the laser timer in order to make the robot move, time to move, and the
Mm-hmm.
publisher. So meanwhile, the actions server starts with the send goal. I activate the timer, and uh, I do my function time to move, which it's the in order to uh, do the robot following the wall
Right.
and
And then you
advance.
have those if else for the walls. If it's too close, turn to the left. If it's too far, turn to the right. And then
Yeah,
blah, blah, blah.
and inside of the timer the, and function time to move,
Uh huh.
I ask for the is goal done, which is a variable inside of the action class.
Right.
And if it's true, it means that
You can
the action
stop the movement.
server is completed. So I stop the robot, and I cancel the timer.
Oh, you stop that timer. Oh, nice.
Yeah, and that's it. The transfer scan is the same to the filter scan. So
Okay, okay. Yeah, to take a
let's
range
not talk
of
about that.
values.
Yeah.
Cool.
And on the main, I create a turtle class, and I add in extension of the turtle class, like which is a client turtle class and service turtle class, and I put the turtle and the action client inside of the multi-thread executor.
Mm-hmm.
I don't put the service client class because I spin inside
Right, I see, I see.
of the turtle class, so it's not necessary. That's why I comment.
Mm-hmm.
And then I spin, and that's it.
That's great. That's awesome. Do you mind stop sharing your screen? Because I think
Okay.
it's we're pretty much. That was a really clear project, really nice, and so I'm sorry if that was a wrong way of doing it, but I kind of interrupted you just to have a different setup instead of asking you all the questions at the end. So I just wanted to kind of interrupt you like that. But congratulations, Ruben. That's really nice. The only kind of real question I have for you is that you've taken these courses, you've taken ROS 2 Basics in C++ and presented the project. You've taken ROS 2 Basics in Python and presented the project, and also the ROS 1, correct? If I'm not mistaken.
Yes.
And so moving forward, what do you think is the best way for you to develop in ROS 2? Let's stick with ROS 2. Uh, differences between the Python and C++, and what advantages I guess you see for doing things in ROS and C++ as opposed to Python, because we have the sense that C++ is more efficient, but I'm just wondering if you actually saw something tangible in here in this project.
Oh, actually, I still don't make the project of rostering Python.
Oh, you haven't. Then it was
Yeah, yeah,
ROS 1 in Python.
yeah. Just
Oh,
ROS
I
one,
see.
Python,
Then
and C++.
but it's pretty similar. Uh, um, my question in regards to I'm trying to get to what do you prefer using and why?
Well, I prefer to use C++ because
Mm-hmm.
the major of the packages uh, are already in C++. So that's why, and the major of the development on
Right.
ROS
Yes. And
made
that's
in C++.
because it's more efficient and it goes faster, and you can do things with Python to make it go faster. And I think, for example, there's a language called Python, which is, oh, I'm not too sure, but it's like a version of Python with some elements of like C++. That's why it's Python with a C, and to increase efficiency. But yes, most of the work that's done in ROS for production is in C++, so that's a great idea to do this. But that doesn't mean that you can't do a quick and dirty Python node to test things and things like that. So um, I'm glad you're doing both things. And yeah, congratulations again. Pretty nice project and perfectly worked.
So yeah, thanks.
All right, guys. Well, if anyone else that's watching, you can do this if you want to obtain a certificate for our courses. Uh, and this is sort of the last step to learn, um, to really learn something that you take online is to do a presentation like this, show what you know, and then that's the final step, we believe, to get a good understanding of the course you've taken. So I invite everyone else to watch it. And Ruben, thank you very much for your presentation, and we'll see you soon.
Oh.
All right, guys. That's it for us for becoming a ROS developer. We'll see you guys for the next video. Bye-bye. Great.